Hello and welcome to a new video lecture. In this lecture, we are going to learn how to use external interrupts. Let's get started. Here we have got the circuit design. We connect a wire between digital input pin number 2 of our Arduino Uno and one of the push button pins. The second wire of the button goes to the ground pin of the Arduino. This is very simple, yet will help you grasp the idea of interrupts very easily. Both pin number 2 and pin number 3 allow usage of external interrupts on Arduino Uno. Please check the documentation if you are using a different Arduino version. The idea is to trigger an interrupt by pushing the button. The interrupt is simply an event that is invoked and it triggers a method to be executed once it happens. Interrupts have the highest priority of all and immediately stop the execution of the main loop and trigger the handling method associated with them. Then once completed, it returns to the normal execution. It's one of the essential concepts in microcontrollers. It can be used for many applications like triggering a safety mechanism if a car crashes, or fire an alarm if a sensor is pulled up high, and so on. Let's start the coding. Open a new sketch file. Start as usual with a hash include software serial.h. Inside the setup method, type serial.begin on 9600 and inside the loop method, type serial.println micros. Add a delay of 2 seconds. Let's save the file. And upload the sketch to the Arduino. Let's open the serial monitor and now we can see the micros printed on the screen. Remember that micros counts the microseconds that has passed since the beginning of the execution of our program. Every time we reset the board, the micros are reset as well. So far we have got a running program that performs a repetitive task, and here it is a simple printing. Now let's make pin number 2 function as an input connected to a pull-up resistor using pin mode, pin number 2, comma, input underscore pull up, close the brackets and semicolon. We could have added a resistor to one of the pins of the button, but it's easier this way to focus on the concept rather than wiring more components. Next, let's attach an interrupt to this pin number 2. In order to do this, we use the method by Arduino API attach interrupts, and we pass the pin number, but we wrap it inside the function digital pin to interrupt. This will basically perform a masking on the input port and return the pin we are interested in. Next, we pass the method that will be triggered once the event happens. That is comma fire me. This is a method we will define later. Next, comma, we define the action that will trigger the interrupt. In this case, we use one of the constants of Arduino API, change. Close the brackets and semicolon. Now let's define the fire me method. It's a simple method, void, it does not return anything. And we type down inside the brackets of the method serial.println high interrupt. Let's upload the sketch to the Arduino board and open the serial monitor, and we can see here I have triggered the button so it prints high interrupt. Now let's push the button once again and observe what's happening. Here we go. And since my button is not very smooth, there is a rough transition between on and off states, and that's why it triggers high interrupt multiple times till it's stabilized. You can actually try the same exercise without any buttons using 2 wires and connect them on the run. Now I'm trying again to make sure it is consistent. As you can see, it works nicely. Inside the fire me method, let's type down detach interrupt, digital pin to interrupt, pass the pin number 2, close the bracket semicolon, Ctrl S and save and upload. Now it's uploading. It's done uploading. Open the serial monitor, and here we can see that it's printing the redundant loop. Now if I push the button, we should see high interrupt only once. This is because we detach the interrupt on the first invocation. That is, we allow it to run only once, and the first time it runs, it detaches itself. Now that you know how to attach and detach an interrupt, let's see how to disable and enable interrupts. Interrupts are enabled by default on Arduino IDE. Inside the setup method, type down no interrupts. In order to enable interrupts, we type interrupts. But since they are enabled by default, let's disable them by typing no interrupts. That will disable all the interrupts at the beginning of the execution of our program. But be careful, we are doing this only for the sake of illustration purpose, but in real life scenarios, disabling interrupts would hold some functionalities counting on them. Let's save the file, upload the sketch. It's done uploading. Now let's open the serial monitor, and no matter how many times I push the button, the loop will not be interrupted and the printing will continue. Another useful pattern in some cases is to write down no interrupts inside the loop method and afterwards type down interrupts. That will disable the interrupts and do some logic, and afterwards enable the interrupts. In between the two invocations, perform the atomic logic you need. This is useful when there is a conflict between connected peripherals that depend on the interrupts. It's one of the tricks that might save you a couple of days of debugging when you implement your own projects. Let's quickly wrap it up. You have learned what interrupts are, what they are good for, and how to detach interrupts to single digital pins, and how to enable and to disable interrupts globally. Thank you, and see you in the next video.